Welcome to ClickMyProject.com. Now we are going to discuss about the project speech emotion recognition based on attention MCNN combined with gender information. Now we are going to discuss about the abstract of the process. Speech emotion recognition is an important task in the field of feedbacking system as well as the customer services. In this process, we present a approach to the speech emotion recognition based on the feature extraction and classification by using the MFCC as well as the machine learning algorithms. These are the two major steps involved in this project to extract the features as well as to classify the features to recognize whether the input having the which kind of speech emotions. The main objective of this process is to develop an accurate and efficient model of recognition and classifying the human emotions based on the recorded audio as an input. So the user can give the input audio. In this sense, the system model will recognize the emotions of the persons. The emotion may be the sad, happy, angry, so whatever it is, the system model will recognize automatically based on the features of the input signals. These procedures involves to the emotional content of the speech. We employ the various machine learning algorithms including the support vector machines to classify whether the input signal is the which kind of emotions. The final output will be the emotions and then the performance will be evaluated based on the accuracy, sensitivity and specificity, finally the error rate. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the following steps like input signal, pre-processing, feature extraction, classification and finally performance estimations. These are the 5 steps involved in this project. At first, the input signal is taken from the dataset. The dataset consists of the various kind of signals which is having the various kinds of emotions like happy, angry, sad, discussed, so whatever it is. So after getting any one signal from the dataset, the pre-processing will be carried out. In this pre-processing, actually 2 stages will be there. One is the signal reshaping as well as the noise filtering. So in this signal reshaping, in case if the input signal is too much of in the size, it should be replaced and then to limit the size of the signal. So the reason is, in case if I am giving the higher range of the signal in this sense, it will take too much of time to the execution. That is the reason we are importing the signal reshaping method here. After doing the pre-processing, the feature extraction will be carried out. So in this feature extraction, the MFCC features is applied to extract the features from the signal. After continuing with the MFCC, we have to extract the mean, standard deviation, variance, minimum, maximum and the energy of the features will be evaluated. So after extracting these features, it will be generated as an test features. After doing the feature extraction, the classification will be carried out by means of the machine learning algorithm. So classification consists of the 3 steps of input, which is having the test feature, train feature and label. Test feature is the feature of the input signal, then the train feature is the features of the overall dataset signal, then the label consists of how much number of emotions we have to be classified. For example, if I am having to classify the 4 kinds of emotion in the sense, the labels will be the 1, 2, 3 and 4. So likewise we are going to do the classification. After doing the classification, the result of the classification will be in the form of emotions. After doing the classifications everything, the performance will be evaluated by means of the accuracy, sensitivity and the error rate. So the accuracy will be evaluated based on the formula like true positive, true negative, false positive and false negative. Now we are going to discuss about the running procedure of the process. At first, open the Matlab 2019b and then change the current directory like this. Once you want to execute the process, just right click in the main file.m and select the option run. Once you selected the option run, the dataset will be open. In that dataset, you have to select the any signals from the dataset. Now the dataset was open. In that dataset you can see the several kinds of expressions will be there, like angry, fear, happy, neutral, sad. So everything will be there. So we have to open any dataset from. After playing the input audio, we have to discuss the results one by one. Now this is the input signal which we have taken from the dataset. So the input signals having the time as well as with respect to the amplitude. This is the input signal which the user can select. So the user defined signals will be shown here. User can select any signal from the dataset, whether it is an happy, sad, or whatever it is. So after selecting the input signal, the spectrum coefficients of the signals will be shown here. So the x-axis of both the signals will be same with respect to the time durations. The y-axis will differentiate based on the amplitude and then the frequencies. So these are the difference between the input signal and then the output signal. So after doing the spectrum efficiency everything, so we have to do the MFCC. MFCC is a kind of the feature extractions. Here we are doing the Cepstral coefficients to extract the features from the signals. So the MFCC will be appear to look like a image forms. So after doing the MFCC, the values of the MFCC will be extracted. So those values are plotted in this table format. These are the values which represents the test feature, which means these features of the input signal. After doing the feature extraction, the classification will be carried out. In this classification, the angry is classified. So the input signal is based on the angry only. So the signal is classified as angry by means of the classification. After doing the classification, the performance will be evaluated. So these are the table which represent the performance by means of the accuracy, sensitivity, and specificity. After doing the performance estimations, so the performance values are shown here, and the accuracy is around 98%, sensitivity is around 97%, then the specificity is around 99%. So the final graph will shows the results of the proposed and existing of based on the parameters accuracy, sensitivity, and specificity.